A child holds a sled on a frictionless snow-covered hill inclined at an angle of 29 degrees. If the sled weighs 88 newtons, find the force exerted on the rope by the child. So the first step is to draw a free body diagram. In this case, we have an incline, so I'm just going to draw a little sketch of the incline, and then I'm going to put my object on the incline and then draw all the forces that I can identify. First of all, I have the weight pulling down, and then I know that there is a normal force, the force of the incline pushing up on the object. And lastly, it refers to a child holding a sled. So they're obviously holding it because it's not going down, so they're holding it maybe with a rope or something. They're pulling it up the sled. So we're going to call this the force of the child. It's unique. Okay, so there's our forces. Then one of the shortcuts that we have is we know by geometry that if this is 29 degrees here, then this angle here is also 29 degrees right here. Okay, so we know that just because of geometry. And I'm going to say that this is the positive x-axis, and I'm going to say that this is the positive y-axis. And so we're really going to rotate everything. So we have two forces that are parallel to our axes, and we only have one force that has both an x and a y component. The force of the child is only in the x direction, and the force of the normal is only in the y direction. This just makes it a little easier because instead of breaking two vectors into components, we only have to break one vector into components. So this is the way we're going to be actually writing out our problem. So this can be broken down, and instead of measuring from the positive x-axis counterclockwise, which is the way we usually measure angles, since we already know this angle, we're going to define the components relative to this angle instead of from the positive x-axis counterclockwise. And in doing so, it's just a little shortcut, and it's going to simplify the problem. So this one here, this is the component of the weight which is parallel to the y-axis, and this one is the component of the weight which is parallel to the x-axis. So we're going to call this the weight perpendicular to the x-axis, and this is going to be the weight parallel to the x-axis. Now the weight perpendicular to the x-axis, it's the y component of the weight, and we can use it by finding a value relative to this angle. Notice this is the adjacent side of a right triangle, and so we can use the cosine function to find the adjacent side of a right triangle. So the weight perpendicular is equal to the weight, which is the hypotenuse of this right triangle, times the cosine of 29 degrees. Okay. And the weight parallel right here, it's the opposite side relative to this angle, and so we're going to use the sine function for that. Even though it's the x component, because we're not measuring from the positive x-axis counterclockwise, we can't use that sine cosine, relative to x and y. We have to instead identify each side relative to the angle. So this is the opposite side, and so we would say the weight times the sine of 29 degrees. Now, in addition to the cosine function finding the y value and the sine function finding the x value, because we define it not from the positive x-axis counterclockwise but by this angle, we also have got to put in the value of the direction. So in other words, this is pointing in the negative y direction, but the cosine of 29 degrees is going to be positive. So we're going to have to put a negative sign here. We just need to be aware of that. Also, this is pointing in the negative x direction, but the sine of 29 is going to be positive. So we're going to have to put the negative sign in. You just need to keep that in mind when you take a shortcut. You have to know some things. Okay, so let's go back here, and we're going to start doing our guess method. And we know that the sled weighs 88 newtons. So the weight is equal to 88 newtons. And we also know that the incline has an angle, we're going to say theta, of 29 degrees. We're just going to write that down, even though we've kind of already used it. Okay. And then we're going to write down our unknown. This is just a declaration to make sure we know exactly what we're looking for, because there's a lot of things you could find out in this problem. We're looking for the force exerted on the rope by the child. That's just going to be FC. Put a little question mark there because that's what we're looking for. Then the equation, we are utilizing Newton's second law. So sigma F is equal to mass times acceleration. Okay. Now in this case, we know that the acceleration is going to be 0. Therefore, the product of the mass and the acceleration is also going to be 0. So let's break these into their components. First, we'll write our substitution. I like putting this in the substitution part. So we have sigma F x is going to be equal to the force of the child in the x direction plus any other forces. Are there any other forces? Yeah, there's the weight in the x direction. And then the normal force is purely in the y direction. We know that because there's no acceleration, that this is equal to 0. So the net force is equal to 0. Forces are balanced. Okay, we can define these in terms of the original vectors. So what we do is we say Fc times the cosine of 0 degrees. Now, why is it 0? Well, if we go back here, Fc is pointing in the positive x direction. If we measure from the positive x-axis counterclockwise, this is where we start, which is 0 degrees. That's why this is 0. Now, the weight in the x direction is the weight parallel. We did not define it in terms of the positive x-axis counterclockwise. We took a shortcut. Therefore, we need to use this value. We're using the sine function. It's because of our shortcut. Also, we have to put in a negative sign. So it's going to be minus w sine 29 degrees. And that equals 0. Okay. Now, this will solve our problem if we put in our values. So we know that Fc times the cosine of 0 is just going to be equal to Fc, because cosine of 0 is equal to 1, minus 88 newtons times the sine of 29 degrees. And the sine of 29 degrees is equal to 0.485. That's equal to 0. So we multiply that by 88 and you get 42. So Fc minus 42.7 is equal to 0. Add 42.7 to both sides and Fc is equal to 42.7 newtons. So that's our answer. If this were a bigger problem, we would go back and we would define some of the forces in the y direction, and that's going to be equal to Fn, the normal force, plus the weight in the y direction. This is the normal force in the y direction. Those also equals 0. And then we could proceed on. We've already found the answer, so we can stop there.